big. No, you can. That is fine. Just know at any time if you like hop over to the left side column, totally fine. Okay, we are going to start by graphing these. And I tried to mimic the same setup that Mr. Paintner uses just because he's worked a lot more with these. And the first thing you guys want to do is simplify and factor it if you can. Just because it's easier to look for those key numbers that we're going to need. So when you look at example 11, can the numerator be factored? No, the denominator, how does that factor? X plus or minus 3. And then depending on what the assignment says, like your homework assignment starts with saying like find the domain restrictions. Domain restrictions are anything that could be a hole or anything that is a vertical asymptote because those are the x values that can be used. Is this function going to have any holes? No, because a hole comes when you cancel things, so we're not able to cancel anything. So, for holes, there is none. Vertical asymptotes. Where does a vertical asymptote come from? The denominator equaling 0, because like the big rule of fractions is the bottom of your fraction can't equal 0. So what two x values would make our denominator be 0? X equals 3, and then x also equals negative 3. So domain-wise, that means our domain would be all real numbers except x cannot equal what two numbers? Plus and minus 3. So just know, if you're being asked to find the domain, it's really just saying, are there any holes, are there any vertical asymptotes? Because those are the two things that like wouldn't exist on your graph. In a different color, I would build it as you go. Vertical asymptotes, put them in something. You can do a dotted line, you can do a solid line. If you put it in a different color, it's not as important to dot it because then I know like, oh, this is what they're getting at there. So, vertical asymptotes, can our graph ever equal a vertical asymptote? No, that is the line that we can never ever cross. Horizontal asymptotes, we can cross horizontal asymptotes. For the horizontal asymptote, this is where you look at the degree. So what is the degree of the numerator? 2. What's the degree of the denominator? 2. So they have the same degree. So if our degrees are the same, how do we find our horizontal asymptote? If you flip back a page, eats, exponents are the same. What does that DC mean? Divide your coefficient. So this is a 4, this is a 1. What's 4 divided by 1? When your exponents are the same, you divide your leading coefficients, and that will be where your horizontal asymptote is. So horizontal asymptote, we also have one up at 4. So you're kind of segmenting your graph into different areas. The graph is going to kind of be like pattern based as to what areas it can fall into, but just be aware like we've kind of sectioned it off into 6 pieces. You can cross a horizontal asymptote, and if you were to cross a horizontal asymptote, what you want to do is you want to see, does this equation ever equal our horizontal asymptote? This is where you might need to like slide over to the other side. When you equal these, what number is really underneath this 4? Whenever you have a fraction equal a fraction, this is where you can cross multiply. So cross multiply means multiply your diagonals. Multiply your diagonals. I'm just going to multiply this in right away and set them equal to each other. So when you cross multiply, no more fraction. And then we just want to solve this if we can. How would you get your x squareds on one side? Subtract them. When I subtract them, what's 4x squared minus 4x squared. Does 0 equal negative 36? No. So that means that this graph is not going to cross their horizontal asymptote. So that's just kind of like a plus to figure out, does it actually cross? This does not give us an answer, so we know it will not cross the horizontal asymptote. I'm going to erase just so that I can keep my stuff in one area, but that's how we know it won't cross it. X and Y intercepts. We'll do the y-intercept first. At the y-intercept, what is the x value? 0. So plug in a 0. What number do we get out? 0, because you have a 0 on top. 0 divided by negative 9 is 0. That ordered pair, we plugged in a 0, we got out a 0. We plugged in a 0 to find the y-intercept, we got out a 0, so we know it crosses right there. To find the x-intercept. At the x-intercepts, what does y always equal? 0. So to find the x-intercepts, this is where you set it equal to 0. You can write the factored form in these ones. I'm just writing x squared minus 9 because it's less to write. If a fraction equals 0, specifically what part of the fraction has to equal 0? The numerator. If a fraction equals 0, it's because the top equals 0. How do you move the 4? Divide it. How do you undo the square? Square root it. So what does x equal? 0. Because 0 divided by 4 is going to be 0. Square root of 0 is 0. So where does this graph hit the x-axis? 0. Same point. That's fine. So in a previous unit, you guys found x and y intercepts. Monday is when we talked about all the asymptotes. So this is kind of where college algebra can start building on itself. When we look at this graph, we only have 1 point. So then to get more points, you just pick numbers that make sense to help you fill in what the shape of this graph should be. So if we know 0 is a number, what other number should we plug in? 1 and negative 1. And then we obviously have different sections of the graph. So then you want to plug in other numbers on the sides of your asymptotes. So negative 1 and 1 are both kind of in this middle section. So I would plug in like negative 4 and negative 5 because that'll give you the left side of this asymptote. And then what other two numbers should we for sure plug in? Because now we would have the left side, the middle, 4 and 5. Okay, everyone just pick one number. If everyone picks one random number to plug in, we won't need to spend our time plugging in 6 numbers. You can plug into either form. So you can plug into the beginning form, or you can plug into the factored form. You're going to get the same answer. When you punch this into your calculator, just be careful because you would do like 4, 1 squared divided by, and then you need a parenthesis to show this is what I have in the denominator. So just make sure when you punch it all in, if you're punching it all in at once, you need parentheses around your whole denominator so that it knows it all goes together. Anyone get 1? Negative 1/2. Anyone do negative 1?
Yes.
Negative 1. What did you get? Negative 1/2. Negative 1/2.
Yeah.
Negative 4. Anyone do negative 4? You got 2 point something?
No, that's all of them.
What? 64 over 7? What's 64 over 7 as a decimal? 9.1?
Oh. Wait, do we get negative 4 already?
Yeah, is it 9.1?
Oh.
I got negative 8.
Shouldn't be negative. Oh, you got a negative 4. Okay.
25.
Decimal.
I don't even
Hit math.
You're not getting it.
Oh, yes, that makes more sense. All right, negative 5, 6.25. 4. Do you guys agree? 4 is 9.1?
Yeah.
5 is. So obviously, in the grand scheme of this graph, that's not that many points. However, the asymptotes will help you. So as you're plotting these points, 1 is a negative 0.5. Negative 1 is negative 0.5. Negative 4 is like 9.1. Negative 5. Our asymptotes are lines we get close to. Do we cross our horizontal asymptote? No. So when you connect these dots, just based on those 2 points, we know that it comes down and then eventually it's going to level off to that asymptote. On the other side, again, it's going to get close to its asymptote, then it's going to level off. And then this one in the middle, since they're both down, we know it's going to get close to those asymptotes and then level off. It is not guaranteed that these two are always going to be the same thing. Sometimes you'll have like one up, one down. They're not necessarily this symmetric all the time. That's why you always want to do a couple points in each side of your asymptote. But use the asymptotes to help you, because once you know what direction it's going, it has to go off to the asymptotes. Any questions on that one? Okay, underneath it, first thing we want to do is factor it. Can the numerator be factored? No. The denominator, how would that get factored?
Plus or minus 2.
Does anything cancel? No. So with anything not canceling, what sort of thing do we not have? We have no hole. Do we have a vertical asymptote? Negative 3 and 2. And then if you're asked about the domain, that just means our domain is all real numbers except for what 2 things can x not equal? Negative 3 and 2. Your domain is only going to be only going to be ruined by a hole or a vertical asymptote, because everything else it could technically equal. You know that these lines are going to be on here, so you can just add them right away. horizontal asymptote. This is where you look at your exponents. What is the degree of the numerator?
1.
What's the degree of the denominator? 2. So the relationship, where is it bigger? Bigger on the bottom. So if it's bigger on the bottom, where is our horizontal asymptote going to be? Zero. So if it's going to cross the horizontal asymptote, that would mean our whole equation would have to equal 0. Horizontal and slant asymptotes can be crossed. So if you have an asymptote, you want to set it equal to that value. Our asymptote is at 0. If a fraction is going to equal 0, what part of it has to equal 0? The top. Technically what you're doing is you're multiplying this whole thing over. But what's 0 times anything? 0. That's why you can just set the top equal. So where does this graph cross its horizontal asymptote? So we know one of our points at x equals -2, it is crossing that horizontal asymptote. Okay, so we have our asymptotes. Now we have to figure out our x and our y-intercepts. Your y-intercept. At your y-intercept, what is your x value? 0. So just plug in zeros. Where is our y-intercept? -1/3. So -2/6, -1/3. So that means our ordered pair, -1/3, 0. Nope, I wrote that backwards. 0, -1/3. So x is 0, we went down 1/3. Do you see how, like, shape-wise, this is already kind of starting to build itself? We have 2 points in the middle. Our x-intercept, at the x-intercept, what do we set our whole function equal to? 0. If a fraction is going to equal 0, what part has to equal it? The top, we already did it. Where's our x-intercept? Which we already have. If you've already found something by chance, I would still just go through the practice of re-finding it, just because once you get in a flow, these get a little bit more logical, I guess. Yeah. 0, -1/3. So go down 1/3, -1/3. So we have our stuff. Now we just need our additional points. Just make sure you have enough points in each region where you know what's going on. So, like, what would be the left side? What are, like, 2 numbers we would for sure want on the left side? What's to the left of our asymptote? If you want to be, like, extra good on your graph, what other number would you also put in? -6. So if you are someone who's like, I don't know if I'm seeing the pattern, the more numbers you plug in, the better your graph will be. But bare minimum is 2. If we have -2 and we have 0, what would probably be the one other number we would want in that middle section? 1. And then what numbers would we want on the other side? 3 and 4. And then again, 5 would kind of be a bonus point, just like -6. The more points, the better. Minimum is 2. When you guys plug it in, make sure you're using parentheses. And then sometimes it's easier to plug into your factored form, especially if you are someone who like enjoys doing mental math, I guess. Because if you plug in a -4, what's -4 plus 3? -1. So if you are just plugging these in, -4 plus 2 is -2 divided by parenthesis, -4 plus 3 is -1 times what's -4 minus 2, -6. So if the whole thing is getting confusing as to how you plug it in, you can plug into your factored form and just like do the parentheses in your head, because the parentheses should be fine for you. Just do like, oh, -4 plus 2 is -2. And then same thing on the bottom, and then it's a lot less punching in because you're just doing the top divided by this times this. Is -4 1/3? So 0.3? So -5 plus 2 is -3. -5 plus 3 is -2. -5 minus 2, -7. 3 over 14 should be 0.4 or something. What did we get for -5? Way off. Did anyone do -6?
0.08 and then
What for 1?
for
-6 was 0.08.
yeah, 0.08.
Anyone do 1? What? 0.75? I don't know if some of you guys are just like really good at drawing on your papers right now, but this is the difference of like I get it or I don't get it. Like this is the worst part. We gotta practice the worst parts. Are we all okay with punching these into a calculator? I don't think it should be 0.75. Negative 0.75? Three? Three. 4. 0.4. 5 if anyone did it. What did you get? For -6? I don't think it should be negative because we can't cross this again.
What's the number for 3? 8?
0.8.
Okay.
Alright, graphing these ones. Connecting them, knowing we cannot cross our asymptotes anymore. So this graph would start low, go high. What does the middle section have to do? Where does it start? High goes low. And then the last section, where does it start? High because the other points after it go down after.
So you just follow it?
Yep, you follow it. Knowing that you cannot cross asymptotes, that's where you kind of just like use the lines to guide you. Okay, last one. Step 1, what do we do? Factor it. Up top, what do we do to factor it? Take out an x. What's going to be left over? Good, x plus 3x minus 3, because it's going to be an x squared minus 9. On the bottom, what's the first thing you should do? Take out a 3, because then that'll change it to an x squared minus 2x minus 3. How do you get negative 3, negative 2?
3 plus 1.
And then the x minus 3's cancel. So our actual function will be x plus 3 over 3, x plus 1. Do we have any holes? Yes. Where is that hole? What's the x value of the hole? Close, 3. So if we canceled out the x minus 3's, if you set those equal to 0, that means the actual x value is a 3. Now our goal is to graph this, so we need to actually know where does this hole exist. So how would we find the y value that goes with it? Plug it in. Can you plug it into the original or your new one? The new one. It doesn't exist on the original. So you plug that 3 in, because if we need to graph it, we need to know the x and the y value of it. It will be a fraction. So give it as a decimal. $1.5. I'm not going to put this one down just because I know what's to come in this problem, but that's where we're going to have an open circle on our graph. I just want to make sure it's orientated correctly when we actually do put it on. So, not going to put it on the graph yet. Vertical asymptote. Do we have any? Yes. Where is it at? -1. So when you're finding your vertical asymptote, the 3 doesn't count because it was removed. That 3 is already built into the hole being there. So when you're finding your vertical asymptote, it's what's still there after it can't be reduced anymore. The 3 doesn't have an x, so that's not going to affect anything. So your domain, it would be all real numbers except for what can't x equal. -1 and 3. Because the holes and the vertical asymptotes would be the things that it's not going to be able to work out with. Horizontal asymptotes. What is the degree of the numerator? And you go to the original for this. 3. What's the degree on the denominator? 2. So if you're bigger on top, do we have a horizontal asymptote? No. However, do you notice how the numerator is 1 more than the denominator? So the numerator is a 3, the denominator is a 2. So when that numerator is 1 more, this is the only time we are going to get what sort of asymptote? A slant. This is a tricky problem. This is not meant to be something that, like, I still want to challenge you guys. I don't want this class to just be something that it's a repeat of Algebra 2, a repeat of pre-calc. So, slant asymptotes are goofy. This is kind of a tricky one to find your slant asymptote with, because when we go to the original, and we put this in here, it's extra goofy, because how do you make an x? I wrote that backwards. Are you guys gonna let me do that? The top goes inside. bottom goes outside. Top goes first, top goes inside. All right, variable wise, how do we make an x into an x to the third? An x. Number wise, how do we make a 3 into a 1? 1/3. So this needs a 1/3 x. We're used to making it bigger, but you can make it smaller because dividing by 3 is the same as 1/3. Anything you put up top, you now multiply down on the sides. 1/3 times 3x squared is just going to be x to the third. What's a third of 6? 2. So it's minus 2x squared. What's a third of 9? 3. What do we now do to our signs? So the x to the thirds are gone. And then here, like, in reality, this is how you guys are going to run into things. Do you see how my stuff isn't lined up? So just make sure you line it up. Is there anything to go with this x squared? No. So that's just going to stay the same. It's a 0. And then your x's, what's negative 9x with a 3x? All right, x squared to x squared. Does it need a variable? No. But how do you make a 3 into a 2? And then this is where you check it to see if you actually did it right. What is 2/3 of 3? 2. What's 2/3 of 6? Negative 4x. 2/3 of 9. Or use a calculator. There is absolutely no reason to have a calculator stop you. So 2/3 times that number, 2/3 times that number. If you're using a calculator, just make sure that 2/3 is in parentheses. What do you then do to your signs? And kind of the same thing here. Our x's will what? Just become a 2x, negative 2x, plus 6. Can we make an x squared into an x?
No.
No. So this is our remainder. In a slant asymptote, your remainder does not matter, so you don't need to continue on. Your answer is right there. So our slant asymptote is at 1/3 x plus 2/3, which is goofy. But a slant asymptote is just any diagonal line. Is that going to be a diagonal line? Yes. When you graph it, this is where you want to make sure you're careful. And this is where, like, showing all of your work really helps me, because the likelihood of this being exactly correct are kind of slim. But if I can see, like, this is their slant asymptote, this is their whole, all of this stuff, then we can kind of figure it out from there. Where does this graph start for the slant asymptote? 2/3. What is its slope? Up 1/3. So you keep that spacing. So if you start at 2/3, when you go up 1, you're at the next 2/3. 1, 2, 3. You go up 1, 2, 3. Again, keeping 2/3 with a 1/3 slope is tricky, but we should be close. I can see your work on the side, so if it gets a little bit off, nothing to worry about. What other asymptote should I put in there? X equals -1 for our vertical. And then here's where I'm now going to put that hole in there. Do you see why I waited? So if I go to 3, 1.5, is it going to be a little bit above the line or a little bit below the line? we started at 2/3 and then we went up 1/3. So think of we're always at a 2/3. Is a half bigger or smaller than 2/3? Smaller. So 3, 1.5. Just put an open circle. It's not going to be perfect, but it should be right below that line. So that's why I waited to put that dot in there, because if I would have put the dot in there first, chances are I wouldn't have had it in the right spot to the line, because these numbers are close. They're not always going to be this close. Sometimes they are. What other numbers should we plug in? Oh, we need our intercepts. Y-intercept. What number do I plug in to get a y-intercept? 0. Where's our y-intercept at? 0. And then our x-intercept, instead of plugging in a 0, now what do? Set it equal to 0. And if you want to save yourself some time, what part would equal 0? The top, the bottom, or both of them? The top. So if I set just the top equal to 0, reminder, where's my solved one? That's what I'm setting equal to 0. So what does x equal? 0 and -3. So the factored version is going to be quicker to solve. So we know it crosses at 0, done. We know it crosses at -3, which is right there. So it's a lot of little things to keep track of, but this is where you just have to be organized, and as soon as you start trying to take shortcuts, that's probably where things are going to fall apart. So just don't take any shortcuts.
Would that x be plus or minus?
So the minus is taken care of because it ended up canceling and that gave us our whole. That's a good point. So the reason when you were doing it, I just went to this one instead of the original one is because that 3 was canceled away to give us our whole. So factored version is good there. Extra points. What should we do to the left of this one? We already have -3, so what other two numbers? Let's just do two other numbers there. -2, -4. And then on the right side, we already have 0, we already have 3. So if we wanted to do two other points there, what would be two good ones? 2 and 4, that works. The further away you go from your asymptote, sometimes you might get like a bigger or smaller number, which could make it more or less helpful. So just know, like, you just got to find numbers, plug into either form. This one might be easier. So you can plug into either that form or this form, but you just have to plug in, and that's where it's going to take time. All of these problems should have a boatload of work with them, and that's honestly what I'm going to be more so looking at. Because at the end of the day, if you're just copying your graphs off of Desmos or your graphing calculator or something like that, that's not as meaningful as, like, do you remember all these fun little rules?
Check this out.
Anyone get -2? 4 numbers. We need 4 numbers. 4 people plug in 1 number. We can be donezo. Hunter, do you have one of them? Bailey, do you have one? What did you get? For -2?
It's 0.67, sorry.
For -4? You got a negative? Positive 0.66? Very exciting, right? Very exciting.
For 4, I got 1.9.
Yeah.
For -4, I got -0.4.
Negative 0.04.
Point four.
Okay. So negative 2 is above, negative 4 is below, which matches our asymptotes. Negative positive 2, 1.1, so that's just going to be barely below. 4 is 1.9. And then once you hit that hole, make sure you don't go through it. Make sure the hole is visible to say like this value does not exist.